Converting between polar coordinates and Cartesian coordinates, an important skill when working with polar coordinates. Consider the diagram below. You can see that we have an x-axis here and a y-axis here. The point P here, in terms of Cartesian coordinates, is x along here and y up here, so the coordinates would be x, y. But note we also have the distance from the origin and the angle. And so in polar coordinates, it's r theta. Using ordinary right-angled triangle trigonometry, since y is the opposite and x is the adjacent, we can state that x is equal to r cos theta and that y is equal to r sine theta. And when converting in this direction, so that's going from polar to Cartesian, there's no need to worry about the angles. It will work wherever we are around the four quadrants. When going the other way, we can see from Pythagoras' theorem that r is equal to the square root of x squared plus y squared, since r is the hypotenuse of this right-angled triangle. Remember, though, that we do have the four quadrants. All angles positive, so all sine, cos and tan positive in there. Sine only positive, tan only positive, cosine only positive. Remember that the inverse tan only returns answers between -90 and 90. So we can use the inverse tan of y over x to find an angle. Very often we just use the positive values because we're only interested in an acute angle. But sketch when converting in this direction to make sure that the angle is in the correct quadrant. So remember, that's when going from Cartesian to polar. So you don't need to worry, polar to Cartesian, but it's a good idea to sketch when going Cartesian to polar